Today we're going to discuss descriptive measures. Descriptive measures in statistics are categorized by measures of the center, measures of variation, measures of rank or position. Today we are going to focus on a measure of variation, very important to the study of statistics, the standard deviation. The standard deviation for a sample of data is denoted by the letter lowercase s. It's a measure of variation of the values in the sample around their mean. The standard deviation for a population is denoted by Greek letter sigma, which is a measure of variation of the values around the population mean. In terms of the formula, on the top of the slide you see the formula for calculating a sample standard deviation. S is the square root of the sum of x minus x bar quantity squared divided by n minus 1, the sample minus 1. Whereas for the population standard deviation, sigma is the sum of x minus mu quantity squared divided by uppercase N. In terms of finding the standard deviation of a sample by hand, the first step is to determine the mean value for the sample. In this case, you add up the elements in the sample, 6, 7, 9, 11, and 12, and we end up with a sum of 45. When we divide that by the sample size, which is 5, we get x bar, the mean, equals 9. In our next column of data, we're going to subtract x bar, which is 9, from each element of the sample. 6 minus 9 is negative 3, 7 minus 9 is negative 2, and so on. If you sum that center column, since x bar is the mean or theoretical midpoint of the sample, the mid column sums to 0. In the right-hand column, we square each of the results in the center column so that we have 9, 4, 6, etc. And that sums to 26. So that 26 represents the sum of x minus x bar quantity squared. When we divide that by the sample size minus 1 and take the square root of the result, that gives us then the standard deviation. In this case, the square root of 26 divided by 5 minus 1 gives us the square root of 6.5, which gives us a standard deviation of approximately 2.55. What that tells us is that the elements of this particular sample vary from their mean value by a typical or standard amount of 2.55.